Hello everyone, welcome to the sprint demo for Evernym Indy teams. And the agenda for today is to discuss the results of the current sprint, plans for the next sprint, and show you 4 demos. 2 demos from the Indy Node project. Sergey will tell us about recent improvements in simulation tests and corresponding architecture and code improvements to have more advanced simulation tests and to follow our message-driven architecture more. Then Nemanja will show us our changes and improvements regarding the zeroMQ logic, which should also improve our stability and simplifies the code a lot. For the SDK side, Nikita will show us improvements regarding verifiable credentials, and in particular being able to use multiple attributes from the same credential. And well, the main result of the current sprint is stable releases for the both Node and SDK teams, and Vladimir is going to briefly tell us what is in these releases and go through the changelog. So this sprint for the Node team was mostly devoted to stability fixes and various improvements. So in particular, we did a couple of fixes related to view change. Then we've been working on improvements regarding transaction auth agreement. And as I mentioned, we continue improving our simulation tests, test coverage, and corresponding architecture improvements. And the important result of the current sprint is stable release 1.12 of Indy Node. For the SDK team, the team is mostly, again, the main result here is release. It's 1.13. And also the team continues working on the test suite, test harness, in particular applying tests for libvcx implementation. Okay, so let's start with the first demo. Sergey?
Okay, let me share my screen. Hopefully you can hear me as well as see my screen. I'm going to tell a bit about improving simulation tests to include processing of instance change messages. First of all, why and what are simulation tests? Well, main idea is to test more with less effort. And in order to do this, we use reproducible pseudo-random source. We simulate time, simulate network, and inject all those data into nodes using some simulated environment. And as a result, first of all, we don't need to wait in real time, so simulation tests take much less time than usual integration tests. Environment is fully controlled, so tests are fully reproducible. And as a result, we can run thousands of them with some random message processing, with some random message delays. And all this helps in either improving our confidence in our implementation or helping uncovering some insidious edge cases. The problem with Indy Plenum is that in the beginning, its code wasn't designed for that kind of testing. So we have lots of integration tests, but we didn't have simulation tests actually until we started implementing PBFT view change. And the reason behind this is that node and replica classes are quite entangled monoliths, and there is no easy way to inject something into them. And solution is to extract some pieces of functionality as self-contained services using incremental refactoring. And we already done quite a lot of this work in scope of previous PBFT vChange implementation. For example, we started ordering service, checkpoint service, vChange service. However, this was, this is not enough. Now, onto vChange triggering topic. General idea is that we should watch out for some signs that current primary is malicious or misbehaving, or probably just offline. Upon finding those signs, we should send instance change messages to other nodes, and when we get quorum of those instance change messages, we should start vChange. And before implementing Indy 22.6.3, watching was spread across node old vChanger class and new vChange service. Instance changes were sent immediately, and old vChanger class processed both sent and received instance changes, and it wasn't quite good. Well, it wasn't quite good in implementation. There was some hacks, and vChanger was tightly coupled with Node, and so it wasn't testable in simulation environments. So our simulation test didn't take processing of instance changes into account. So our simulation tests were not full enough, probably. And after implementing this task, things are much better decoupled. Watching is moved into some specialized monitoring services, for example, primary connection monitoring service. Those services send word for vChange message. They don't broadcast instance change immediately as was done previously. And the reason behind this is that handling of all instance change messages is done in a single vChange trigger service. So on receiving word for vChange, it broadcasts instance change, and on receiving quorum of instance changes, it tells already implemented vChange service that we should start a vChange. And these new services are isolated and testable in simulation environment. And as a result, code is greatly simplified. Simulation tests and we have much better confidence in our simulation tests. Pull requests with this implementation, unfortunately, is not yet merged, but it will be merged very soon. And I'd like to show some code of new services, for example, primary connection monitor service. It's actually quite straightforward. We just process some events, connection, disconnection, primary selection, and node status updated. And if we compare this with some of old code, for example, node code, you can see that some pieces of functionality, for example, on connection changed, was quite complicated, and it was spread across all over this node class. So that's all from me. Do you have any questions?
Thank you, Sergey. It was very useful. I think that shows how we're improving our code and how we get more confidence. So let's eventually it's easier to contribute, it's easier to understand what's going on. So I think it's very important. Okay, the next demo is from Nem. So please share screen.
Yeah, here we go. So the ticket I was working on was related to zeroMQ reconnection logic because of the way we used monitoring sockets for identifying some events that happened on the ZMQ layer. We disabled effectively the zeroMQ logic that handles reconnection. So now we wanted to get that back, and we didn't want to have manual logic to see if a socket reappeared on the network or a node kind of restarted or rebooted. And when he's online, we wanted zeroMQ to handle that for us. So we needed to remove that and change that, tweak is a better word, tweak that logic with monitoring sockets that we had. So currently, if I am to show some code, is one of the main methods where we use this monitoring socket is this get monitor events for each remote that we have on the node. For each remote socket, we always have a monitoring socket that enables us to spy on events that are happening and always see if the connection is still alive, if a disconnect happened, if an error happened, and handle it appropriately. The major change that was done here, and it's a small one, is that we closed monitoring sockets when we disconnected, but when we disconnected manually, but when we noticed that we have a network partition or the node crashed or rebooted or disconnected without us triggering the action, we didn't close that socket. So basically it's a one-liner here. We now just close monitoring socket when we notice that a disconnect happened. So this is either a bug or a behavior in the zeroMQ library, because if you don't close the socket and the socket is effectively dead, after a period of time, zeroMQ goes into a while loop and he begins looping forever without stopping, and it blocks the entire network layer. So this was an easy fix that enables us to use characteristics and behavior of the zeroMQ library without us really having code that we're triggering manually. So the next steps would be to remove the code that we had once we prove that this is all working. Right now, this change is merged, but we're having a small issue with behavior, because behavior with auto-reconnection of zeroMQ changed a bit. So compared to our previous logic, so we need to iron that out, but it should be done, and it should be fixed soonish. So here are the tests. I mean, they're test reconnection after successive disconnects, after random disconnects, multiple restarts, long and short periods of timeouts. We test if the data is same, if every message is delivered correctly. And I just wanted to show you how this works right now and how it didn't work previously. So right now we have, this is the best way to show it. We have 4 nodes here. I'm running 1, 2, 3. I'm showing you. So I'm going to reboot node. I'm going to stop node number 3 and show you that now node 1 sees it's alive. It has an established socket. If I stop it, node 2 immediately noticed that a disconnect happened. If I need to zoom, so you can see that out of 4 nodes, node 2 is now only connected to 2, now not 3 as previously. And if I show you the sockets. There are no sockets anymore. So now, if I just start this node, when it comes online, you will immediately see that the reconnection happened. Come on. Yeah, so reconnection happened. If I show you node 2 logs, it connected, it identified both node 1, node 4, and now node 3 that rebooted, and everything is working correctly. If you want to write something, everything works. So that's about it.
Thank you, Nem. Yeah, it's a set of very good fixes which also can improve our stability and simplify the code a lot. Well, so the next demo is from Nikita, and this is about SDK recent improvements. It looks like Nikita has some audio issues.
Do you hear me now?
Yes, now we hear.
Awesome. So, the whole work started with a bug report where our people from community asked us to that they need to query for some attributes from the same credential. So they need some more intricate and interesting restrictions for the query for credentials, and they've submitted a pull request, but it wasn't really it hasn't really fit our standards, and we didn't really want such implement this functionality that way, so we've made it by ourselves. So right now it's merged, and it's already in stable build of libindy. So what has been made? Wait a second, here. So we introduced a new parameter. It's called names. It's applicable only for attributes and not for predicates. When we query, we can use either name or names for the attribute, not two of them at the same time, and there should be at least one of them. So names is an array that contains attribute names. If you put it that way, functions like Indy prover get credentials for proof request will search credentials that has all of these names at this, all of these attributes at the same time, and functions like prover create proof will create credential will create a proof for the from the one credential for this attribute, for these attributes. We've created tests we create several tests to show how it works. So here you can see that you have a referent for some attributes, and we have parameter names. You can add other restrictions as well, like for issuer ID, for schema ID, and so on. So let's launch the test. So here we can see it's running. It's running pretty long because it creates a lot of a number of credentials, schemas, and credential definitions. It goes still. So what this test actually does, it takes proof requests and queries for the credentials. And here we just looked at there are two of credentials that fit this proof request. When we initiated the wallet, there are 4 credentials created. 2 of them fit and 2 of them are not. And what is interesting, that we have a credential that has values that only one parameter fits and the other is not. So as we can see in proof request, there is name and sex, and here only sex and some other kind of height. So the test is passed and it works. I can launch the test for verify and approve, but it's less representative from this one. So that's it, and this is the new functionality that we create for proof request.
Okay, thank you, Nikita. It was a useful improvement required by community. And the last demo for today is from Vladimir. So,
hello, let me share my screen. Can you see it? Okay, so I'm going to tell about our latest releases of Indy Node and Indy SDK. At the Indy Node side, we have released 1.12.0 release, and it contains primary selection algorithm improved. Now we take into account transaction history when recovering state for new nodes, and we fixed new nodes adding when there are old house rules and plugin transactions and ledgers. So now it can help us to avoid issues with incorrect state recovered on new nodes that were added to the pool. Also, as you can see, many fixes were made during the last 2 sprints, and also we have issued Indy SDK release. It contains LV6 areas support, so several RFCs were implemented. It contains implemented connection RFC, implemented credential issuance RFC, and implemented credential presentation RFC, and also integrated connection protocol into dummy client agent. Also was added names parameter to proof request revealed attributes that what is Nikita said about, and also we there was a bug fix with Boolean representation in Java wrapper. So I believe that's all. We have Indy Node stable release 1.12.0 and 1.13.0 release of Indy SDK now in our stable repos. So that's all from me.
thank you. Well, and let's briefly discuss the plans for the next sprint. For Indy Node, the next sprint will be mostly bug fixing, stability fixing. In particular, we are going to process a couple of issues found by community, and continue working on simulation tests improvements, code improvements, and fixing some issues and improvements related to view change. On the SDK side, the main goal is to continue working on areas test suite, and also work on some stability fixes and bug fixing. So this is the plans for the next sprint, and most probably till end of this year. And in January, the plans are to continue working on new features. So that's all. Thank you, everyone.